Okay, we are live, and I will start recording.
Cool.
All right, everyone. Howdy. Hello, and welcome to the IPFS weekly call, where we get to learn the great things that are happening in our community and stuff that we're building. Today, let's see. So before we begin, if everyone can just, if everyone can just fill out the IPR weekly call list. So if you're attending a call, just put your handle in under the attendees section. So we don't have any announcements for today. So we'll begin. We'll begin with the main presentation. But before we begin, I want to thank Ali for taking notes. Thank you, Ali. And today's main presenter is Michael Rogers, and he's going to talk about GitHub ecosystem metrics, the project he's been working on for the past several weeks. So Michael, please take it away.
Cool. Starting the broadcast now. Let me know when you can see it. Cool. Okay, I think I'm sharing now. Awesome. Okay. Let's go to contents. Okay. So this is going to be a little bit kind of experimental. Anyway, so the system that we built uses GH archive. And so this is something that GitHub puts out, but basically every hour they put out a file, right? And it looks like this. And it has, so it's an hour of public data. So every single piece of it's metadata for every single action that anyone takes across all of GitHub public resources. So any push, any people watching the repo, people commenting on things, anything like that. There's only a couple things that it doesn't really pick up. Like if you emoji thumbs up something, it doesn't pick that up. But it's a very large amount of data. So if you go back like maybe 2 or 3 years, you end up with like a couple terabytes worth of data. But because of rate limiting and a bunch of other stuff, this is really like the only effective way to look at entire ecosystems across GitHub. So what we really wanted to do was like be able to query this in a saner way. And so what we devised was essentially the system where first we can like identify repos. And the way that we do that is like, we might want to look at a dependency graph for all of the repos in IPFS. And so that would give us all of the entire dependency network. And then we want to sort of look at all of that repo set across all of GitHub archive. Or we might use BigQuery or something like that. And like with BigQuery, we could actually look at, they have a snapshot that they update, I think like monthly, of every single file and every master branch across all of GitHub. So that would allow us to say like, oh, well, like what does the Docker ecosystem look like? So what are all the repos that have a Docker file in them, things like that. So you can get really useful information of that. BigQuery is quite expensive though. So we really need to limit those queries. Like that query to query those Docker files is probably like $15 to run it like once. So we identify repos in one step. And then we basically, we want to get a filtered set of data. And I'm going to explain how that system works a bit here. So we use Lambda, and what we do is that we ask Lambda for a month of data. So that Lambda function is called filter month. And what that ends up doing is creating between 28 and 31 requests, depending on the month, to filter day. And then filter day is going to make 24 requests to, another Lambda function called, no, sorry, not filter, it's called pluck. And so what pluck is going to do is it's first going to check, like, do we have that GitHub archive file for that hour in S3? If not, we're going to go and get it. And then once we put it in S3, we use this thing called S3 select. And S3 select actually, it allows you to do like SQL queries on either CSV or JSON data. And that data can even be lines of JSON in a gzip file. So it actually works perfectly for GitHub Archive. Except every couple months, somebody will do a gigantic push to GitHub with a lot of file updates. And even the metadata about the push is larger than 1 meg. So what happens is that this entire pluck function crashes in like in an uncatchable way. And so when that happens, we fall back to this thing called pluck fallback. And this is a much slower version of S3 implemented in Node.js that just does the exact same operation. And so what happens is that with both of these, what they're going to do is they're going to return just the attributes out of the objects that we want into filter day. Okay, so coming back to this initial piece here, when we call filter month, we also give it what we call sort of a filter. And so that has, that's like an encoded CBOR object, basically. And we store it in S3 so that we don't have to pass it to the Lambda functions because they can actually get too big to be passed around between the Lambda functions sometimes. So that CBOR object has not only just these pluck values in it, but also any repositories that we want to filter out. So what pluck day will do after it gets this pluck set is then filter out all of the repository, all of the information just for the repositories that it cares about. And then filter day is going to store that in S3. So what you end up getting in this filter month request, actually, so let's like, is you end up getting just a bunch of files for every single hour of data that you ended up filtering and plucking. And then we do another Lambda function called concat, and that concats all those files together and stores the new value in S3. So when we go and get a year's worth of data, we basically just do a month at a time. A month is going to generate between 700 and 1400 Lambda functions, depending on caching, and those are all going to run in parallel. So if it has to hit pluck fallback, it'll take a little bit longer because the whole set's going to go as slow as the slowest request. But in like less than 10 seconds, we'll get back an entire month's worth of data. And then we do a month at a time. I would love to pull a year at a time. We got the Lambda rate limit increased, but then as soon as the rate limit was increased for Lambda, we noticed that there's also an S3 rate limit. So now we were blowing out the S3 rate limit once we started to actually use our new Lambda limit. So we're trying to figure that out. Hopefully we would eventually just be able to do a year at a time, and then we could pull a year in about 10 seconds. But as it stands, we can get 3 years worth of data in less than 10 minutes. So it's pretty fine. But the nice thing about this system is that because we're taking the CBOR object here, we're not limited in terms of like how many repos that we can query for. We can literally filter for 100,000 repositories. It would take a little bit longer because each of those are going to have to decode this giant CBOR object out of S3. But we can do really, really huge sets of data. That's one of the reasons why we couldn't use some of the off-the-shelf stuff like BigQuery's. BigQuery also has all this activity data in it, and other than just being cost prohibitive, there's a limit on the size of the SQL query that you can do. So being that there's this limited SQL query, we can't like jam 100,000 repos in there. So we'd have to chunk through them, and then it would be insanely expensive. So yeah, this is basically how we can. This allows us to pull in a very reduced data set of just the values that we care about for just the repositories that we care about in an ecosystem. So what ends up happening now that we have this system, is that as long as we can basically turn an ecosystem into repositories, we can then filter out a data set for those. And then it's just a matter of like actually processing the metrics. And this is sort of the stage that we're at now, where we're trying to figure out useful data that we can get from this, right? So you can do things like we can get the unique like people that are engaged in different kinds of activity or all activity. So we could say, who are all the people that committed to this ecosystem? Who are all the people that engaged in any way? So they're even in, sort of issue comments and stuff like that. So you can assume that they're like users of the system. You can also just look at, the overall level of activity, right? Like, is this ecosystem coming down, or is it still sort of, rising in terms of overall activity? And then most importantly, you can take all of that data and you can start to look at like, well, what is the growth rate of that ecosystem? How much is activity and unique users growing over different time slices that you want to look at? So yeah, this is sort of what we're doing with the system now. The main reason that I wanted to sort of show people the system and how it works is that it's a little bit different than traditional metric systems where you log the metrics in some database and then you can do queries on it. We actually have to, go and filter this giant data set from GitHub and then get interesting metrics out of it from there. But with it, we can look at not just our ecosystems, right? So for IPFS and P2P and all these other systems, but we can look at ecosystems that we're interested in maybe getting involved in, right? As we're doing package manager work, we can say like, okay, well, what is the growth of Docker files compared to package JSON files, and how many people are engaged in those? And one of the interesting things here is that when you look at different ecosystems, the number of packages in a package manager may be growing, or just the number of Docker files may be growing in different repositories, but there may be really big differences in the number of users of those ecosystems. When I did this analysis 4 or 5 years ago using much worse tools, just separating out sort of back-end JavaScript from front-end JavaScript, there was like a noticeable difference in the number of people engaged in those front-end projects. So you could sort of correlate that to there are more people using those actually. There's more users of these projects than the backend projects. So this gives us like really interesting sort of competitive analysis between different open source ecosystems as well. So yeah, I think at this point I can open it up for questions. This isn't like a gigantic talk. Yeah, let's go with questions.
You're probably showing me myself. Okay. Thank you very much. And for those who have questions, if you just put it in the chat box, that would be great. So are there any questions? I have a question.
Mm-hmm.
It seems like you are at the point where the data is clean enough for you to analyze. Have you seen anything of interest in terms of people who are contributing and activity on IPFS?
It's a little bit too early to walk away with like really big takeaways. We're still sort of refining how we do the repo identification piece. So like right now for repo ID, I'm using the library's IO data. And there's a pretty big discrepancy between like GitHub's dependency. So if you go into your GitHub repo, there's like a dependence tab and you can see all the repositories that depend on your repository. There's a lot more repos there than in the library's IO data. Probably because library's IO is doing like a really complicated operation where they're trying to look at repo data that is in the package JSON and then correlate it back through the dependency graph. But not everybody has that metadata up to date. Whereas like GitHub, has all of the repos themselves. So they know if a package JSON depended on that package name somewhere. They can even pull, repositories that are depending on it that aren't published in any way. So that's really useful. So yeah, but the problem with that data from GitHub is that there's no API. So I've been poking them to try to get them to give me that data in some usable way without me like literally writing a scraper through their website. But yeah. So I've looked at sort of like looking at sort of the data ecosystem and our ecosystem. And one interesting thing is that so far, the projects that are in a similar space to us have a very similar sort of curve in their growth. So it looks like the space that we're in, the sort of decentralization space, is growing at a particular rate, and we're all growing in it really well. So that was one interesting kind of takeaway. But I'm sort of waiting to get more data and to refine our repo identification before I make a lot of other judgments about it. Also, like I really want to look at more mature ecosystems and see sort of like where their growth hit particular spikes and what the different curves went, and see if you can find correlations between them. And then we can look at our growth and say like, okay, well, like what phase of adoption are we in and which phase of maturity are we in terms of ecosystem development? We don't have great stuff on that yet. We literally like just got the system sort of working, and then every time that it works, then we like make some improvement to make it a little bit faster, and then that blows out a new rate limit that we didn't know about somewhere, and then we hunt that down and then add a new layer of caching, and that blows out some new rate limit because things are faster. So a lot of sort of like, if you look at the repository, there's just like a lot of churn in the code and the methods that we're using to get to something relatively stable. Now, essentially like at this filter month phase, there's effectively like a rate limiter inside of it that tries to estimate the potential number of Lambda functions that it'll call, and you can basically just change that.
This question is very similar from Johnny Crunch. So any interesting insights so far?
I think I kind of covered that. I covered as much as there is so far. My main insight is that Lambda is like super powerful and can do this kind of stuff like really fast. Like if you're running this locally on your own machine, it would take like a month. And, you can do it like a lot quicker. However, there are really, really nasty, fairly undocumented rate limits on everything. So, and also, this is like not a common use case in the Lambda world. Like bursting from 0 to thousands of functions and then back down to 0 is just not as common. So we're hitting a lot of like weird things with that.
Next question from Ollie. Have you got any exciting headline stats out of it so far? Any surprises? And I guess that would be not yet, because you're still in the early phases of analyzing the data, right?
So right now I'm trying to just provide the data to the projects, and then I'll let the projects decide what kind of top line numbers that they want to pull out of that. I will just sort of caution generally against top line numbers. Like all of these are estimates, right? Like not all of our users engage in a public repository. Not all of our users publish a public repository. We also like don't have a great way right now to look at the Go ecosystem, right? Like their package management situation is pretty bad. So like the dependency network stuff that we do for JavaScript projects doesn't work there. So we're gonna have to figure out something like in BigQuery, analyzing every Go file in GitHub and trying to figure out if they are using IPFS inside of a Go file to identify repositories. So we're missing some data there. So we're in the stage now where we're just kind of trying to refine it, where I wouldn't want to pull out top line numbers. I think that the most you would want to pull right now is just growth rates, right? Like the growth rates, if we're not sampling enough or we're potentially oversampling, if we compare that to another ecosystem, the same biases should remain, and so we should be able to compare growth rates at least, even if we know that these numbers aren't going to give us an exact number of people all the time. A completely accurate number of people. I think there's also something that we need to think about where the more that you sort of traverse into a package's dependency network, the more that you're sort of in passive usage rather than active usage, right? Like people didn't actively say, hey, install IPFS for my thing. They installed something that installed IPFS or installed an IPFS client, essentially. And so you may also want to separate that out. You may want to say like, just one level of depth or maybe 2 levels of depth in that depth graph is as far as we want to go. And the rest of it, we're going to kind of separate out. So yeah, right now we're figuring out like the best ways to look at this data and slice it up. And I wouldn't want to pull out a top line number of people right now. Yeah.
All right, excellent. Thank you. Next question is from Rob Brackett. Are there any specific uses we're planning to make from all of this info?
So I'm trying to feed some data right now into the process that we're doing around package managers. I really want to find good ways to measure these ecosystems so that we can provide into the decision-making process that data. We also just had a quick metric sprint where we were just trying to get a bunch of data out of a few different projects. So that gave us some basic info on the packages in the orgs for libp2p, IPFS, and IPLD. And so we were able to see like, okay, like what is the sort of growth rate right now in just activity on our own projects, stuff like that. But yeah, the whole sort of like across the organization, the sort of metrics and KPI situation right now is like just log data, like figure out how we get data. And then we're once we have a lot of data, then we can start to talk about the best ways to use it and analyze it. So yeah, this is like a lot of what this presentation is meant to do is to open up the possibility of questions that you can ask about data, because now we can capture this entire ecosystem data. And please sort of feed these kinds of questions back into the process, and we can improve the tools and run these regressions again, and start to feed more and more metrics and data into the overall process.
Thanks. Next comment is from Jim Pick. He said, I'd love to see some cohort analysis, see how many people are contributing, and then churning it out.
Sorry, what was the last part? Turning it out?
Churning, churning it out. CHURNING, churning.
Churning it out. I'm sorry, what's the question? I'm like confused about the question. Sorry.
It wasn't a question, it's just a comment.
Oh, okay.
Yeah.
Okay.
Next question from Andrew.
Yeah,
can this be used for analyzing the content of Docker files?
So we would use BigQuery for that. So BigQuery can look at the contents of all of the Docker files in all of GitHub, and then from that we would get a set of repos. So if we wanted to have some kind of matching inside of the Docker file, then that would tell us, like, you know, if a Docker file has this thing in it, tell me about it, or tell me the repo name, or tell me the file, or whatever. And then we could then do a filter analysis across all of those repos in the archive. But this system itself doesn't have the contents of all the repositories in it. BigQuery is quite good at that, and replacing that would be pretty massive. And I mean, and not a huge win for us, because the types of queries that we need to do on the actual file contents right now are pretty minimal. Like, you know, we just need to see if something matches usually. So we can, you know, pay, you know, $15, $20 or whatever a query, get that data, and then have the set of repositories, and then have like this much more cost-effective system to look at all of the meta-analysis about those repositories. Hope that makes it clear.
Awesome. Those are all the questions. Are there any more questions? That seems to be about it. If we don't have any questions, then we can end early.
Cool.
Right. Another one from Andrew. Could this be used to cluster package data together?
What do you mean by that? Andrew, you want to just talk for a second?
Andrew?
There we go. Sorry, I just had to plug my mic in.
No worries.
So what I was thinking there was, rather than just like a repo that has a match for some content in a file, but like, are there kind of clusters of repositories that all say use these 5 packages, and what is the then crossover of like other group packages that would be often used together to kind of highlight collections of similar or shared bits of code. So like, our IPFS libraries always being required along with these kinds of things, maybe probably libp2p related stuff, for example, but also can we highlight similar kind of groups of types of dependencies that people are using with IPFS to get an idea of where there might be almost like an Amazon recommendation for stuff that is closely related to a given set of packages. And I'm really mostly interested in IPFS packages, particularly there.
Yeah, you couldn't use this for that, but I think you could just use the GitHub API, right? So, well, okay. First, you'd have to crawl that dumb dependency thing that they don't have an API for. But once you found all of the repos in GitHub that actually depended on it, then you would just look at their package JSON and then start to basically log all of the packages and see what are the kind of top ones that were required alongside. And then you could use this system to then do an analysis of those repositories and find people that are the most active in those ecosystems as well. So you could start to like include the IPFS ecosystem alongside stuff that is used with it, and then do an ecosystem analysis of all of the people and activity across both of them and see what the correlations are there.
Okay, cool.
That would be interesting.
Okay. Any more questions? Well, it seems like that's it. Thank you, Michael, for your presentation.
Yeah. Well,
Okay. And I will see everyone next Monday for the next IPFS weekly call. Have a great week. Take care. Bye.
yeah.